Hello, this is the notes for Unit 3, Lesson 1. We're looking at solving quadratic systems. This is the first part of two parts for solving quadratic systems. Today we're looking at linear and quadratic functions as well as quadratic and quadratic functions. Alright, so the first thing to remember, we're looking at solving a system. That means you're solving for where the graphs intersect. Okay, you can see how many different possibilities there will be. They could all be a little bit different. You won't always get two solutions. You won't always get one solution. It's possible you could get zero if they don't actually intersect. All right, so remember that you're solving for coordinates. So just when you found your x value, or you found one value, you're not done yet. You've got to make sure you go back and plug that in and find the corresponding y value. Okay, that's very important. So let's go ahead and look at some graphs of functions first. All right, so remember, these are systems, okay? To solve them, you want to see where they intersect. Let's look at this first one. Where does this intersect? That's the point -3, 0. How about the next point? That's going to be up here. That's the point 2, 5. Okay, so we just solved the system using a graph. All right, for a lot of what we're doing, you could plug these equations into your calculator, graph them, and see on your calculator where they intersect and solve it that way. There's also something called the intersection function on your calculator that you can use if it's not an integral point. But we'll do more of that in the next lesson. So for now, go ahead and try the next one with that ellipse and the line going through it. Tell me where that intersects. All right, so you should have gotten these 2 points here. These are the solutions for that system. Okay, you're just looking for those intersections and the integral points. All right, so let's do it algebraically. You're given two functions, f of x and g of x. F of x equals -x minus 2. G of x is x squared minus 4. So the question is, how do we set this up? The big thing to think about is that f of x is another way of saying y. G of x is also y. So both of these functions are equal to y, which means what? Which means that they're equal to each other. So you can say that x squared minus 4 equals -x minus 2. And then you just have an equation that you solve. So it's a quadratic equation, set it equal to 0, combine like terms. Okay, and this you can factor. This factors to x plus 2, x minus 1. So your values for x are -2 and +1. Okay, remember, we're not done yet. These are just the x values. You're going to get 2 points here. All right, so these are just the x values of each point. You need to plug these in to get the y values. All right, so you can pick any of these two equations, either of these two equations, because they're intersecting at the same points. So whatever you're most comfortable plugging it into, you can do that. So I'm going to use the x squared minus 4. So I'm going to do -2 squared minus 4. 4 minus 4 is 0. That goes with x equals -2. Now let's do x equals 1. 1 squared minus 4. Well, 1 squared is 1. Minus 4 is -3. All right, now you have 2 points, x and y value for each point. You've solved the system. Okay? Go ahead and try number 2, there to the right. Okay, so you've got, if you just got the point 1 and -9, that's correct. They only intersect at one point. If you think about it, it should make sense that it's possible because this is just a horizontal line. Y equals -9. So this is just a parabola that opens up, that touches and connects at the vertex. That's where the intersection is. This is the vertex of g of x. That's the only way this could happen. Okay, so that's one of your possibilities. Getting one solution is possible. Okay. All right, let's look at quadratic and quadratic systems. So these are two quadratic functions. Okay. Well, this first one is a function. The second one is a relation. We'll get to that in a minute. So it's really the same thing. It's set up the same. You have f of x and a g of x. Well, those are also y. So that means I can set these two equal to each other. So I get 2x squared plus 1 equals -x squared plus 4. And we're going to work it out the same way as we did the other one. 3x squared minus 3 equals 0. Gosh, Mr. Hilliard, there's only two terms. What do I do? It's okay. Remember, factor a GCF. 3 times x squared minus 1. Now you have a difference of two squares. Factors into x minus 1, x plus 1. So your x part, the x coordinate of your solutions are 1 and -1. All right, so plug those back in. I'm going to pick this equation here, or this function here, 2x squared plus 1. So 2 times 1 squared plus 1 is 3. And then I'm going to do 2 times -1 squared plus 1. Well, that's also 3 because -1 squared is also positive. Okay. Oops, that's not right. Don't do that. Here we are. Those are our 2 points. That's another possibility. They have the same y value. That's perfectly fine. Okay. So let's look at this next one. Now, I called this a relation before. Why did I call this a relation? It's not a function because it won't pass the vertical line test. Look at what's squared. Now we're looking at y squared. Okay. Really, this is exactly the same. Once we work through this, you're going to say, well, what was the difference? Well, next lesson, we're looking at working with circles. And you're going to be solving a decent amount of times. You're going to be solving for y first instead of x. So we want to get you used to seeing that. Okay, so in this case, it's just like the other problems, except they're both equal to x. Well, now I can set these equal to each other. Okay, so add y squared to both sides. Add y to both sides, and the 12s will cancel. These are both positive. Subtract 12 from both sides, by 12. Okay, so then I'm just left with 2y squared plus 8. Again, only two terms. What do I do? It's okay. GCF, take out a 2y, left with y plus 4. Solutions, your y values, your y solutions are 0 and -4. Okay. All right, so we got to find our corresponding x values. We can plug in. I'm going to use this one. So if you plug in 0 to that, you should get 12. 0 squared plus 7 times 0 is all 0, is 12 for x. And then if you plug -4 in, that's a little bit more involved. -4 squared plus 7 times -4 plus 12. Okay, 16 minus 28 plus 12. Okay, so you're looking at, I feel like I did something wrong. Okay, just kidding. So 16 plus 12 is 28, minus 28 is 0. All right, these are your solutions. Okay, so get used to working with solving for y first and then going back and solving for your x component. Okay. All right, go ahead and try number 4, and I'll have the answer when you come back. Okay, so again, you're just setting these equal to each other. You're going to get 2 solutions. Don't forget to solve for y. We need both complete points. Very important to solve for both points once you find them. All right? As always, make a note of any questions you have, and we will see you in class.